Welcome back to the deep dive. Today we're getting into the real nuts and bolts, the plumbing of modern AI systems.
We really are. We're talking about something critical but often overlooked, how an AI agent actually connects to the mountains of data it needs to do anything useful.
Exactly. And we're going to focus on a huge shift, a standardization called the Model Context Protocol, or MCP.
Yeah, you can think of AI agents as, workers on a factory floor. They need tools, they need information from all over the place.
So our mission today is to give you a clear before versus after. Before MCP, you had, well, a bit of a mess. After, you have something much more standardized.
Right. It's the difference between having to build a custom wire for every single light bulb in your house versus just being able to plug anything into a standard outlet.
Love that analogy. So before we get to the fix, let's frame that initial challenge. Why was this such a headache to begin with?
The core challenge is that AI agents need to work with all sorts of different systems. They need your calendar, they need a database, maybe some other processing tool.
And traditionally, getting them all to talk to each other was difficult.
Difficult is putting it lightly. You basically had to be an expert in every single one of their unique APIs.
Okay, so let's unpack that. Let's really pull back the curtain on the pain points. Before MCP, what did this architecture actually look like?
It was pure fragmentation. The AI agent, the brain of the operation, had to manage completely distinct custom APIs for every single service it talked to.
And we're not talking about similar services. Our sources point to some really different examples.
Exactly. Things like, 1, Google Calendar for scheduling. 2, something like a Chrome DB vector store for, semantic search.
Sure.
And 3, maybe a totally separate platform just for heavy-duty data processing.
So these aren't just 3 plugs. They're 3 completely different types of plugs with different voltages, different languages.
That's the perfect way to put it. Different authentication, different data formats, different rules. The AI, and more importantly, the developers behind it, had to juggle all of that constantly.
So if the AI needed to check the calendar, it used one specific custom-built piece of code.
A custom wrapper, yeah. And if it then needed to query the vector store, it would switch to a totally different custom wrapper. It was just a collection of one-off solutions.
That sounds like a nightmare. Just from a development standpoint, what did that fragmentation actually do to the system's efficiency?
It created enormous friction. I mean, every new connection was its own little engineering project. A fragile one at that.
Fragile how?
Well, imagine Google decides to update its authentication method. Suddenly, it's not just one piece of code you update. You have to go back and fix every single agent's custom wrapper that talks to Google Calendar.
So the complexity isn't just additive, it's like compounding.
It is. You end up spending more time managing the connections than you do on the actual AI logic.
And what about scaling? I mean, 3 services is one thing. What about 30?
That's where it completely falls apart. For a big enterprise system, maintaining those 50 different APIs becomes a full-time job of just, putting out fires.
The risk for error must have been huge.
Massive. The more custom pipes you have, the more chances there are for a leak. A tiny change in a data format somewhere over here could crash a workflow way over there.
It's a rat's nest of code.
Mm.
It really begs the question, how can a system built on that shaky of a foundation ever really scale up?
It can't. Not reliably. Developers were spending 80% of their time on the plumbing and maybe 20% on the actual intelligence.
Okay, that paints a very clear and grim picture. So that brings us to the solution. How do we fix this tangled mess?
Well, this is where it gets really interesting.
This is the introduction of the Model Context Protocol, MCP.
And the shift is, it's tectonic. The AI agent doesn't need to speak all those languages anymore. It just speaks one MCP.
Think of it like a standardized shipping container for data.
That's a great analogy. Before, you were building a custom box for every single delivery. Now, the AI just packs the data into a standard MCP container, and the protocol handles the rest.
So let's break down that new architecture for everyone listening. What does the AI agent actually do now in this after MCP world?
The agent's job gets much simpler. It acts purely as an MCP client. It doesn't talk to the raw Google Calendar API or the database anymore.
It doesn't even see them.
Nope. Instead, it connects to a dedicated MCP server for each of those sources.
So it sees an MCP server for calendar and an MCP server for DB. It's a universal interface.
Exactly. And those MCP servers, that's the crucial layer of abstraction. That's where the magic happens.
They do the translation work.
They do all the heavy lifting. They take the standardized MCP request from the agent and translate it into whatever native command the data source, like Google Calendar, understands.
That must be a huge reduction in, like, the cognitive load for the system.
For the system and for the developers,
Yeah.
the AI agent doesn't need to know SQL syntax or OF requirements. The MCP server handles all that complexity internally.
But hold on, aren't you just moving the problem? You still have to build custom logic to talk to Google Calendar. You're just calling it an MCP server now. Where's the real win?
That's a really important question. The win comes from the standardization of communication between the agent and that server.
Yeah.
The agent's code only has to speak one language, the MCP standard. How the request is built, what data it needs, that's all dictated by the protocol. So you're no longer debugging a dozen different communication styles from the agent's side.
Right. So once you've built the agent to speak MCP, it can talk to any MCP server forever. The consistency is guaranteed at that main connection point.
And the time you save in testing and debugging because of that consistency is just monumental.
So system maintenance becomes way simpler. If an API changes, you just fix the one MCP server for it.
Precisely. And that fix is totally invisible to the core AI agent. The agent's world stays stable. You're fixing one endpoint, not a whole web of connections.
All right, let's talk about the payoff here. This move from all these separate APIs to the MCP framework has to change the game for building these systems.
It absolutely does. It moves developers from being reactive, constantly fighting fires, to being proactive and building new things.
So let's tick them off. Benefit one has to be the most obvious. Simplified integration.
Drastically simplified. Instead of weeks writing custom code for a new tool, you're just implementing the MCP spec on a server. It cuts integration time from, weeks down to maybe hours.
And that leads right into the next one, which I think is the real killer feature, scalability.
Scalability is arguably the single biggest win, yes. Adding a new data source becomes exponentially easier.
Because you're not touching the core agent at all.
You don't have to reconfigure the central AI agent one bit.
Yeah.
It remains stable. It just gets told, hey, there's a new tool available at this MCP address. Go use it.
That flexibility is incredible. I can add a whole new database provider, and the central agent just keeps on working without a single disruption.
And that non-disruptive expansion leads right into huge gains in efficiency. The AI spends less time waiting for data to be translated and parsed.
And more time doing its actual job.
More time on its core task. The communication is just faster and way more reliable.
Let's circle back to something you mentioned earlier, security. More custom connections means more places for things to go wrong. How does standardization help here?
Standardization is really the foundation of security in any complex system. With MCP, you can centralize all your security checks, your authorization, your logging at that MCP server level.
So you're not trying to secure 30 different custom endpoints.
Right. You're managing one secure protocol, which dramatically reduces the surface area for any kind of attack. It's just a much safer model.
So if we connect all these dots, what's the big picture here?
The bigger picture is that this shift allows AI systems to scale faster, perform better, and operate more securely. It basically solves the manual labor problem of connecting things together, which frees up so much engineering talent to work on, bigger problems.
So just to sum this all up for you at home, what does this all mean? We started with a total mess.
A fragmented, time-consuming mess where the AI agent was basically a stressed-out translator for dozens of different API languages.
And we end with a streamlined, robust system, all powered by the Model Context Protocol.
The agent speaks one language, MCP, and it relies on these dedicated MCP servers to handle all the tricky translation and security work at the source.
The result is a massive leap forward. You get simpler integration, you get incredible scalability, much better efficiency, and tighter security.
It's just a rock-solid foundation for any modern AI system.
The move from those custom fragile wires to a standardized protocol just delivers better, more reliable operations. It's that simple.
And since MCP really does seem to solve that underlying plumbing problem, it leaves a really interesting question for you to think about. If developers no longer have to worry so much about the logistics of just connecting the AI to data, where do they get to focus all that new innovation? If the connectivity is handled, what entirely new, more complex capabilities can they finally start building?
That idea, shifting all that brain power from the plumbing to the intelligence, that's the real payoff. Thank you for joining us for this deep dive. We hope you feel thoroughly informed.
We'll catch you next time.